everyone, again welcome to the incredible learning experience Jnana Learning. So here I am introducing another video series through Jnana Learning, Gems of Maths. So this includes basic maths, formulas, maths tricks and tips, theorems and many more. So this will be helpful for students and those who are preparing for competitive exams. Hi, today we are discussing about square of a number. So, a perfect square, it is an integer obtained by multiplying a number by itself. So, consider a number a. So, a multiplied by a, that is a square, which is equal to some x. Okay, so x is a perfect square and it is obtained by multiplying the number a by itself. For example, say a is equal to 3. So a into a, that is 3 into 3 is equal to 3 square, that is 9. So the square of 3, it is 9, and we can write it as x is equal to 3 raised to 2 or 3 power 2. So that's it. Now we discuss the important properties of square. So there are 10 important properties. So we start with the first property. Okay, a square number can only end with 0, 1, 4, 5, 6 and 9. A square number will not end with 2, 3, 7 and 8. So see some examples. 16, these are squares. Okay, 16, 25, 64, 81. So it ends with 6, 5, 4, 6, 5, 4 and 1. Property number 2, number of zeros at the end of a perfect square is always even. Clear? Number of zeros at the end of a perfect square is always even. See here, 100, it's a square of 10. We have 2 zeros. Then 2500, again 2 zeros. See another 2 numbers, 70. It have only 1 zero at the end and it is not a perfect square. 3000, it's not a perfect square. There are 3 zeros over here. So that's it. Now property number 3. See property number 3. Square of even numbers are always even. Example 6, it's 36. Even 8 is an even number, its square 64, it is also even. 12, its square is 144, it is also even. Now next property is the square of odd numbers are always odd. That is square of 7, we get 49, it's odd number. 9, it's 81, odd number. That's it. Now next property is that a square number is sum of consecutive odd numbers. That is sum of n consecutive odd numbers is n square. See here, 1, let n be 1. So only 1 square 1. Now 2. So 2 means 2 consecutive number 1 and 3. So it will be the sum of 1 plus 3. 2 square, it is 4. Let n be 3. So 3 consecutive odd numbers, 1 plus 3 plus 5. Now 3 square, it is 9. That is 5 plus 3 plus 1 is 9. Now 4, 1 plus 3 plus 5 plus 7. 4 square is 16. 1 plus 3 plus 5 plus 7 is 16. 5 consecutive numbers, 1, 3, 5, 7 and 9. 5 square is 25 and 1 plus 3 plus 5 plus 7 plus 9 is 25. So that's it. Next property, square of a number having 1 or 9 at unit place end with 1. and 2 or 8. At the unit place, it ends with 4. 3 or 7, it ends in 9. 4 or 6, it ends in 6. Now 5, it ends in 5. You can check it with the numbers. Okay, that is a square of a number having 1 or 9 at its unit place, it ends in 4. Similarly, all the other cases. Now, the seventh property, a perfect square always leaves a remainder 0 or 1 when divided by 4. See here, we take 25 divided by 4. What is the remainder? 1. 64 divided by 4, the remainder is 0. So that's it. The next property, if a natural number other than 1 is squared, it should be either a multiple of 3 or 4 or exceeds a multiple of 3 or 4 by 1. Clear? That is, if a natural number other than 1 is squared from 2 onwards, it should be the square number or the perfect square will be either a multiple of 3 or 4 or exceeds a multiple of 3 or 4 by 1. Let us see some squares from 4 to 100, between 4 and 100. See here, 4, 9, 16, 25, 36, 49, 64 and 81. Let's check this property. Let us take the example over here, 16. Okay, so 16, it is a multiple of 4, that we know. 4 into 4 is 16. Also 3 into 5 is 15 plus 1. So it is a multiple of 4, also a multiple of 3 plus 1. That's it. Okay. Now 25. So it is not a multiple of 3 and not a multiple of 4, but it is a multiple of 3 plus 1. That it is. Either it will be multiple of 3 or 4 or exceeds a multiple of 3 or 4 by 1. Clear? Now to the example 49. So 49, it is not a multiple of 4 and not a multiple of 3, but it is a multiple of 4 exceeds 1. So that's it. Okay. Now the next property, a perfect square can always be expressed as a product of pairs of prime factors. Okay. So see here, 64. I have factorized it into its prime factors as this. By 2, it will be 32, then 16, 8, 4 and 4. So these are the prime factors of 64. So by writing it like this, I have paired it into in this way. Okay, so 2 into 2, 2 into 2 and 2 into 2. So that's it. A perfect square can always be expressed as a product of pairs of its prime factors. Another example, see here for 81, it is factorized as 3, then 27, 3, then 9, 3 and 3. So 3 into 3 into 3 into 3. Again for 144 also like this. So the factors are 2 into 2, 2 into 2 and 3 into 3. Here 225, 5 into 5 into 3 into 3. So that's it. Now the last property, there are 2n natural numbers between the squares of number n and n plus 1. There are 2n natural numbers between the squares of numbers n and n plus 1. See, let n is equal to 4. So n plus 1 is equal to 5. Then square of n square is 16, and square of n plus 1 whole square, that is 5 square, it is 25. Okay. Now between n square and n plus 1 whole square, between 16 and 25, numbers are 17, 18, 19, 20, 21, 22, 23, 24. Okay, how many numbers? Count 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 numbers between 16 and 25, and 8 is simply 2 into 4. So that's it. There are 2n natural numbers between the squares of numbers n and n plus 1. So these are the important properties of squares of a number. Clear? So these are the 10 important properties of square of a number. So see here. So we have discussed the basics of a square of a number. Okay, thank you.